Hey everyone, welcome to Leetcode Weekly Contest 323. I haven't been doing very well recently, so hopefully that changes today. Anyway, wish me luck, hopefully I don't get rate limited, and let's go. Wait, let me just check that actually sorts. Yeah, okay. One point. Okay, so this is just like union find, I guess. Yeah. Actually, I want it to be grid IJ first. if the query has to be better than. Okay. Um, return the blocks as index. Okay. I don't know how fast I am. Zero, 1, 2, 1, 3, 1, 6, 3 minus 1, 0. Okay, I got AC on all 4 problems. I didn't check the leaderboard, so I don't know how well I did. Okay, so I can't quite tell yet because the leaderboard isn't fully updated, but I think I did all right. Anyway, I guess I'll explain my solutions. This problem is very straightforward. Basically, if I was to sort all of the rows at the beginning, then because the order of the elements in the row doesn't really matter. So if I just sort each row such that it's in increasing order, then the operations actually just delete the rightmost column every time. And so if I was to sort every row, the first time the rightmost column will be deleted, then the second time the second rightmost column will be deleted, and so on and so on. So the answer after sorting all of the rows is actually just the sum of the maximum number in every column. So all I'm doing is I'm sorting the rows. This zip thing gets me columns. So for each column I'll increase the answer by the maximum per column, and that's it. Since the constraints are really small, you can just simulate it as well. This question is sort of DP, I guess. The way I'm doing it is, first of all, I'm obviously, since we can rearrange the stuff, like sort the stuff, it makes sense just to sort the initial array. Now I've actually sorted my array in decreasing order, because I'm going to try to find the longest sequence such that each element is the square root of the previous number, i.e. the previous number is the square of the current number. Then that means that if I reverse the logic a bit, that means that if at any time dx is the maximum length of di is the maximum length of a sequence ending with value x, then I simply update d of I as the maximum length of the subsequence ending with I squared plus 1. Like, I could actually write this as well. Like if I really wanted to, I could write something like this as well, but I don't think it doesn't matter. And then, yeah, so you can treat this as a dynamic programming if you really want to think about it, but I think that's a bit complicated. You don't need to think that much. Simply the answer at any time we're maintaining the maximum length of a sequence ending with particular values, and yeah, we'll just update our value as the maximum length of a sequence ending with I squared plus 1. And then we just take the maximum of all of those values. Since the answer has to be at least 2, if t is at least 2, we'll return t, otherwise we'll return -1. This problem is just an implementation problem. The way I've done it here is array x equals to 1 if x is taken, if like index x is taken, and 0 otherwise. And then here, res x is it's a list of all indices with id equal to x. Yeah, so basically the allocator is just make sure you clear these vectors. When I'm allocating something, basically this is the same idea as like run length encoding or whatever, but basically I'm just iterating through all n positions, and I'm going to maintain the maximum number of zeros in a row up to my current point. So any point, streak is just the number of zeros in a row that's from my current position backwards. If my current cell is taken, then I have to reset the streak to 0. Otherwise, I will increase the streak. If the streak reaches size, that means that I have found the earliest block of size 3 cells. In that case, I will take all of those size positions. I will set them as taken in the array in R, and then I'll make sure to update res, because res is the list of indices with all id equals to x. So yeah, in this res for this id, I will make sure I'll add on these elements that I'm now taking. And then to free, it's pretty simple. We just iterate through all of the elements in res of the id, because those are all of the cells with id equal to I. Then I'll simply reset them, increase the answer, and then finally I'll clear this vector. That's pretty simple. Each of these operations, both of these take on time, but since constraints are small, that's actually good enough. Okay, in this problem, essentially, like, first of all, we have to think about what is the question asking. The question is asking for each query, what is the size of the connected component involving the top left corner, where all of the cells in the connected component have values less than my current value. Nice typo, by the way. So for example, if the query is 5, imagine that I had a graph where I have a node at every cell, and specifically I only have nodes at cells with values less than 5. And imagine if I add edges between adjacent cells, then the answer for this 5 is simply just the size of the connected component involving array 1. And basically, I just want to do this for every query. Now, this is a very common idea in Leetcode contests, but the idea is that we don't have to answer the queries in order. Answering the queries out of order is called answering them offline. And basically, what that means I can do is I can sort the queries and I can sort the grid values, and then I can alternatingly like add grid values and ask a query. So basically what I'm going to do is I'm going to create a list of events. Each event is either adding in a cell with a particular value or a querying with a particular value. And if I sort all of those combined events by the values, that means that sometimes I'll be adding cells and sometimes I'll be doing queries. But this is really nice because now we can guarantee that when I'm doing a query, the cells that have been added so far, i.e. the events that we've processed so far, are exactly the events with corresponding to cells being added with values less than our current queried value, which is exactly what we want. So all I'm doing here is I'm creating a list of events. Then for each cell, each of these cells, I'm going to create a new event with the grid cell and the position of the cell. And then for each of the queries, I'm also going to create an event with the queried value and the index of the query. And now if I sort the events, it just becomes a data structures or graph theory problem. All I have to do is for each event, if it was one of these sorts of events, then all I have to do is add the cell to my graph, and add any of its neighbors, like add edges to any of its neighbors that have already been added. And when I process a query, I simply query the size of the connected component involving the top left corner. So now we need to process, we just need a data structure that handles adding a cell, adding edges, and querying the size of the connected component. And this is exactly the disjoint set union data structure. So we are basically done. I happened to have a template which just works for 2D, 2D, 2D disjoint set union or union find, because I think that's common enough. But you could easily just do this with a one-dimensional, union find, and then if you have a cell xy, you can really just treat it as like x times m plus y, and then now you can just use a one-dimensional union find instead, which is probably what I should have done, because this template is really not nice to use. So I think I might actually change that. But yeah, anyway, since all the union finds functions are really fast, this is like, I think it's dominated by the sort. So the complexity is like nm log nm for the sort, or nm plus q, I guess. Anyway, that's all I have for today. Okay, that is very nice. It looks like I've won again, so I guess I won another Apple HomePod Mini. Thanks for watching, and I'll see you guys next time.